In this lesson, we're going to be doing some extra practice with the chain rule. It can't hurt to do extra practice with that rule. All right, the directions are simply find dy over dx. So find y prime by bringing in d over dx. So remember, dy over dx is a label, but within that label, we knew that we were finding the derivative with respect to x, and the d over dx is our derivative operator. Okay, so for number one, I see that I have a constant multiplier of 7. There's not a variable of x along with 7 here to suggest the product rule. So I can get right to the chain rule. And if you want to list the two functions or three functions that compose to create this equation, that's fine. I would think of the outermost function as 7x to the fifth, knowing that's the first derivative I want to find. And then the inside function would be 3x minus 9. All right, so y prime equals, I find the first derivative of just thinking about the power rule and how that's 35, leave 3x minus 9 alone, the g function, drop the exponent to 4, but then create that chain of factors times d over dx of 3x minus 9. So this derivative is easy. It's 3. I can bring it up front and multiply and get 105. For example 2, you could use the chain rule on number 2, or you could actually just FOIL, multiply out this binomial square, and then find the derivative using the power rule on each term. Another option is you could expand this binomial and put them side by side, not foiling, but instead using the product rule, where the first factor is negative 5x minus 8, and the second factor is also another negative 5x minus 8. So for this particular problem, I don't know that the power rule is better, the product rule is better, or the chain rule is better. So it's really up to you. If you feel comfortable with your algebra and foiling, then you might want to do that, FOIL, and then use the power rule. But I'm going to just do the chain rule. So y prime equals, so if you think about decomposing this, maybe your outside function is x squared, and your inside function is negative 5x minus 8. So there's only two functions here. So to get started with the derivative, I would find the derivative of the outside function first. And we leave the inside function alone, but we set it up and say, hey, we got to find the derivative of what I left alone here. This derivative is easy. It's negative 5. Bring it up front. That becomes negative 10. And no matter what other method you chose, whether it's the product rule or doing the algebra and the power rule, our answer is going to be the same. It might look like a different form. It might not be in this factored form, but it'd be the same. Okay, number 3. This is not just simply the square root of x, where we could rewrite that as x to the 1/2 and apply the power rule. We now have more than just x in the radicand, or as the radicand. So however you want to decompose it. So I would say the outside function is square root of x, and the inside function is x cubed minus 7. So only two functions compose this. I might first rewrite this. So notice I didn't go to a prime. Rewrite it in this format. Now I'm going to go to the prime and find this first derivative. So subtract 1 from the exponent returns that to a negative half. And think about that exponent and its effect on x cubed minus 7. It's going to drop that quantity to the denominator to get a positive 1/2, but be a square root in the denominator. All right, and then the setup of the derivative of the inside function. This derivative is easy. It's 3x squared. So y prime equals 1/2 times 3x squared. So that's just 3x squared over 2. I can multiply the 3x squared by the 1/2. And then times, I took care of the 1/2 and 3x squared. This expression, but I think I'm going to go ahead and rewrite it as 1 over and then it'll be the square root of x cubed minus 7. Probably should clean this up. Just create a single fraction, 3x squared in the numerator, and 2 times this quantity. All right, 4. If we kind of glance, there's so many things you can do with 4. I mean, however you want to proceed and where your strengths are, but gosh, it takes me a minute to analyze some of these functions to think about how should I enter into them and begin them. But on this one, let's see, there's so many options. You could rewrite this. One you want to take advantage of, because I would apply the 4th power to the numerator and the denominator. So that would just be 1 over 5x minus 3 to the 4th. And then from here, I'm going to bring up the denominator. Because there's only a 1 up here, there's not a variable x that would suggest the quotient rule. I'm going to go ahead and bring up the denominator to the -4. I like this better just because the chain rule is easy now. All right, so I'm going to go to the derivative. So the outside function is x to the -4, so -4. Now I'm going to go ahead and record that as -5 and then leave the inside alone. This derivative is 5. Where should I put it? Well, I can multiply it into the -4, but of course nothing in this parenthesis here. So I'm going to have -20. And instead of recording this again, I'm just going to go ahead and drop that quantity to the denominator and adjust with that positive exponent. Now, do you have to do this? No. Would it have been okay to be -20 times that quantity? Absolutely. You usually see answers with positive exponents, not negative exponents. No big deal. If you found a different way to solve this problem, if you did the chain rule and then the quotient rule, that's fine. If you want to check your answer with me, make sure it's right. I'd love to kind of look at that. All right, let's kind of ramp up a little bit here. I think we've been dealing with mostly 2 functions that compose to create a problem we were finding the derivative of. I think now we're going to be looking at some more complicated ones, and especially with the trig in them. All right, let's look at 5. Again, attempt them if you want on your own. That's a better way for you to learn and keep that, that knowledge is for you to do it, attempt it, and then you can check the key. All right, I can see a lot going on in problem 5. The first thing I notice is the 4 on the trig function. So that tells me I am going to pull the 4 off the trig function. So when I do that, it's like, how do we handle the 2? So I'm going to take the 4 off the trig function. I'm going to do a big bracket just for clarity here. And then I'm going to put the 4 here. So the question becomes, do I put the 2 inside or do I put the 2 on the outside of this quantity? Well, if you put the 2 on the inside, it suggests that you'd have to take 2 to the 4th power, but that's not what's happening. So I would put 2 on the outside. All right, decomposing this, the outermost function to me, I would see this as 2. Think of this whole thing as x. 2x to the 4th. I got to do the power rule first. Then I have the sine function. And then in the inside of that is 5x squared plus 3. So y prime, I know this is going to be 8x cubed, but I don't put the x down. Remember, I've got that whole expression right here, these 2 functions that have to be my inside function. And then we're going to say times the derivative with respect to x of those 2 functions there. I don't need another set of parentheses because this is just one term here. So I'm looking at this going, well, this is not an easy derivative because it's a composite function made up of g and h. So I'm not going to cross it off. I'm going to actually organize my work on another line. So I'm looking at what's going on here. I've got the 8. I might take that 3rd power and put it back on sine. You don't have to. That's just kind of common practice. Now I'm up to finding the derivative of sine next, which is cosine, but leave 5x squared plus 3 alone. And do the setup times the derivative of 5x squared plus 3. Ooh, kind of getting crowded. This is an easy derivative. That's 10x, sorry. So I wouldn't put it at the back end because it almost looks like and suggests you're multiplying here. I'm bringing 10x up and multiplying it into the 8. So y prime equals 80x sine cubed. And then this is gone, so I just have this cosine expression. I think everything's kind of clear. So I don't think there needs to be a different arrangement of these factors. And what's interesting is if you were asked to look at this expression, how many terms are there? Again, terms are what you add and subtract, but it's not within these binomials because these binomials are attached to trig functions. So if you're asked how many terms make up this answer, it's just one with a bunch of different factors within that term. All right, let's look at 6. Notice the power of 3 is not on sine. We had one similar to this, I think, on our derivatives of trigonometric composite functions. Yeah, we did. 3 is not on the sine function, so I don't have to pull it off like this. So my outermost function is sine. And my next function is going to be x cubed. And then my innermost function is the pi times x. Remember, pi times x is linear. It's just that pi is that kind of weird number. All right, so y prime equals. So I've got to find the derivative of sine first. So that goes to cosine. Leave pi x cubed. But show that you're going to find the derivative of quantity pi x cubed. You know, these two. This is not an easy derivative because it's, again, a composite function made up of two functions. So I'm not going to cross it off. I'm going to just come down here. So I would not put this 3 on cosine. It was never intended to be there. Okay, the derivative of x cubed is 3 pi x squared. I can see 3x squared here, but not x, the inside function, times the derivative of pi x. So this is an easy derivative. Think of pi as being close to 3, so the derivative is just going to be pi. Let's bring pi all the way up front because it has nothing to multiply with. Oh no, there's a 3. I can multiply the pi into the 3 and bring 3 pi up front. Cosine pi x quantity cubed. I see I took care of the 3 and the pi. Oh, and then okay, I see. Pi x squared is left. Yeah, I'm going to take this quantity and bring it up behind this pi because I don't want to suggest to somebody that we're multiplying these two together because we're not. That would not be to the 5th. This quantity is part of cosine, whereas this quantity is not, or that factor is not, I should say. So I've got 3 pi, quantity pi x squared. And you could square that and multiply it further, but you don't have to. Boy, that's pretty ugly looking. It's uncomfortable, but we have to be comfortable with kind of uncomfortable, answers. All right, so let's try 7. Kind of studying the equation before I kind of jump into the chain rule. The outermost function is actually secant. And I see that the 4 is not on secant, nor is it on the outside of this quantity. So actually we just have 2 functions. So derivative of secant would be secant u times tangent u times the derivative with respect to x of 5x to the 4th. All right, this derivative easy, 20x cubed, and I would take and bring it up front. Okay, so let's break down 7. I'm going to find the derivative. It looks, well, let's see, the first thing I'm going to do is take that, I see a power on a trig function, so leave the 7 on the outside of the bracket. Cotangent, close my bracket, and I'll put the cube here. All right, I guess I would think of these two on the inside to be like my x, so 7x cubed would be my outside, then cotangent, and then that quartic right there. Okay. All right, 7x cubed would be 21, 3 times 7, x squared. The derivative of everything that's left alone. This is a composite function, so I'm not going to cross it off. I actually need to get another line here to do the next derivative. So 21, I might put the square back on the cotangent. That way I can lose at least the set of brackets. All right, cotangent's derivative is negative cosecant squared. So I'm going to actually take that negative and go all the way up front and make the negative go on the 21. Cotangent's derivative is negative cosecant squared. So cotangent's derivative is cosecant squared. Leave 2x to the 4th plus 1 alone. But then we still have to find that derivative. Okay, so that's all good here. This is our chain of factors. This derivative is 8x cubed. So I'll figure out how I want to manage that, probably all the way up front. So 8x cubed, yeah. Ew. So y prime equals, it's going to be negative, what's 8 times 21? That's 8, 168. And I had that x cubed with it. So I multiplied negative 21 times 8x cubed. And then cotangent squared. And then cosecant squared. Wow. Not very pretty, but we did it right. Hopefully you found the extra practice using chain rule helpful.